This is rain and snow. Not just a day, or even a year. This is the culmination of almost 20 years of precipitation, all at once. Led by the Global Precipitation Measurement mission, the newest version of the NASA product called the Integrated Multi-satellitE Retrievals for GPM, or IMERG analysis, has remastered almost 20 years of rain and snow, creating a crisper, clearer, and more complete picture than ever before. This marks a major milestone in the effort to generate a long-term record of global precipitation. With this 2-decade-long record, you can see regional and global patterns in unprecedented detail. Seasons pulse. Over India and Southeast Asia, massive monsoon rains shift. Storm tracks march along in higher latitudes. The seas bubble in the Southern Ocean, which scientists consider one of our planet's last great unknowns. If we look a little closer, we can see the wettest and driest places on Earth.
Extreme high events tend to be very concentrated, very localized, whereas the opposite, what we would call droughts, tend to be very widespread and sort of diffuse looking.
The wettest places on the globe occur over oceans, particularly in places where the surrounding land forces air into a converging pattern over warm waters that provide a lot of evaporation. For example, off the coast of Indonesia, as well as off the northwest coast of Colombia. And just 2,000 miles to the south is one of the driest areas, the Atacama Desert in Chile. Across the Atlantic, Namibia experiences some of the least rain as well.
The interesting thing of the last two is that they're right next to the ocean. They're next to cold ocean, and so in fact those dry zones actually extend over the ocean. We tend not to think of ocean deserts, but in fact that's what's going on.
Over the past 2 decades, precipitation has been changing. What we're seeing isn't a change in the overall amount of rainfall, but rather how that rainfall is distributed.
What seems to be happening, and this is still subject to some interpretation, is that the regions that get more precipitation are getting even more, and the areas that get less precipitation are getting even less. You perhaps heard the phrase, the wet get wetter and the dry get drier.
This long record allows researchers to better test climate models by comparing the model's virtual scenario with decades of real precipitation. We're able to go back in time and reanalyze large-scale events, like El Niño.
By making these revised estimates in the past, it gives us better insight into the behavior of the atmosphere, and it allows people who are doing, say, model verification to do a more accurate job of verifying their models for that particular event, which happened in the past, than they could have done at the time.
Improving the models with the past will help predict the future. And that doesn't stop with weather forecasts. A long precipitation record is a vital tool for researchers, modelling floods and landslides, disease outbreaks, agricultural forecasts, tracking our main source of fresh water. All of these applications need lots of data over many decades to fine-tune these statistics and models that agencies rely upon for making decisions around the globe.